morning everyone, thank you for joining me today. My name is Daragh Broderick and today I'm going to be demonstrating to you the capabilities of Fusion 360. So for those of you who don't know what Fusion 360 is, it is a cloud-based CAD package which incorporates a number of different workspaces into the one system. So we've got direct modeling, we've got T-splines and surfacing, we've got simulation, we've got CAM, rendering, and many other capabilities. So hopefully I can take you through as many of these capabilities today in this demonstration. So to begin, I'm going to be demonstrating how to build the outer body of this reciprocating saw. So if I turn on my canvases here, so I'm going to be working from this reference image and I'll be building the body to match this image. So just to give you a quick rundown of the user interface of Fusion 360. So you can see we've got our data panel up here, which is where all our files are stored. So our files are stored in the cloud. You can see we've got upload options, which we can take files from our computer and put them into these folders. You can see we've got this people tab here. So you can add people to projects. So say your engineering team, if you have more than one person, you can add a number of different people and you can collaborate on the same project. So I will be going through this in further detail in the collaboration section of this demonstration. So closing our data panel, we've got our typical options that you'd see in Inventor or SolidWorks or whatever CAD package you're currently using. So you've got your file where you can open new designs, save, export, and so on. You've got your save button and then you've got your undo and redo buttons. So moving down here then, we've got our different workspaces. So we've got our model, sheet metal, etc., simulation and CAM. So I'll be going through these different workspaces as we progress through this demonstration. Like in other CAD packages, you've got your view queue where you can just simply change your views. You've got your navigation panel where you can orbit your model. You can look at different sections, pan, and so on and so forth. A feature of Fusion which is different to other CAD packages is normally you may see a feature tree on the left hand side of your screen. Instead we've got a list of our internal components, our bodies, joints, etc. that we've created in our assembly. So another feature of Fusion which is different is our timeline. So you can see we've got a few features down here at the bottom of the screen at the moment. So as I continue on through this demonstration, this timeline will begin to populate. So I guess I'll begin now by creating the outer body of our reciprocating saw. So just to speed up the process a little bit, I've already created a section of this outer body, and I'll build on to the back portion of this body. So I'm going to be moving into the Sculpt workspace. So you can see we're no longer in the model workspace where we were, but we're now in the Sculpt workspace. So to begin, I'm just going to simply create a face on the middle of our saw. So I can just drag these points out and we've created a face. So I can click OK and then I can select my face and we can go edit form, and this brings up my manipulator tool. So I can simply drag this face out. So I don't want this to interfere with my internal components of our reciprocating saw. So I'm just going to drag it out about that far and we're going to click OK. So now what I can do is I can hide my internal components by just simply hitting V on the keyboard. That'll just hide my internal components, and I can begin to build onto this face. So again, just using the edit form tool, I can select an edge. I can hold down my Alt key on the keyboard and drag out. This creates a new face. and likewise I can just do that again, and we can just drag that in. Then using the same tool again, just drag this out, and same here. And we've created a number of faces in a matter of seconds. So typically in other CAD packages you'd be dealing with 3D sketches, construction planes, and so on and so forth, and then dealing with lofts, sweeps, different kind of features to try build a body like this. So now I'm going to start on the handle. So I'm just going to be using very simple basic shapes like cylinders to create this handle. So I can simply just create our cylinder. I can drag out to increase the length. I can reduce the number of faces that appear on the cylinder. So reducing the number of faces in a situation like this is best practice, because this isn't a complex part at the moment, the handle. So I can just simply move this and manipulate it. Using the manipulator again, I can scale this down, rotate it, move it into place until I'm just happy, just trying to work off our reference image in the background. So I'm just going to take a top view here, and I'm just going to select half of our cylinder and just going to delete half that. So I'm just going to work with one half of this reciprocating saw at the moment. So just to mention, I won't be taking questions at the moment. Harv, Saund, our Autodesk specialist, Fusion 360 specialist, will begin to take questions throughout this presentation. So the goal here now is to create a transition between my cylinder, my half cylinder now, and these faces that I created. So I can just simply select my edges, use my edit form tool again, hold down the Alt key and drag out to create another two faces which I can use. Then I can grab vertices, I can grab edges, I can grab faces, all using this manipulating tool. So I want to create a bridge between these two bodies. So best practice is to match the number of faces you have on one side to the other. So you can see I just have one set of faces here. So what I will do is I'll insert an edge by just clicking here, and I can drag this over, and this will create the two faces that I need to match up. So if I hit S on my keyboard and just type in bridge to bring up my bridge command, and then I can select my edges. Sorry. So if I go bridge, and that side. Okay, I'll just give that a minute now. Of course, it's decided to crash. Okay, apologies for that. We'll just start that up again and we can recover the file. So as Fusion is a cloud-based platform, students don't have to worry about losing files on USBs or hard drives that may become corrupted, or say if they lose them in college or situations like this. So from that side, it's a very beneficial program. Okay, so we haven't lost anything so far, which is good. my recovery, my file recovery, and we can start working again. So I still have my freeform workspace. So all I just have to do is just reinsert that edge again. So I can just simply put that edge in again, click OK, and then using my freeform tool, drag down these faces. And hopefully this time now we can use the bridge tool again. And we won't get we won't crash. Okay, so I can bring up a preview of what my bridge will look like. I'm just going to reduce that down to one face, and we've created our bridge. So I can double click here to select an edge loop, and I can just simply drag that down. I can drag these edges in, again using the manipulator tool, all the while just looking at our reference image, trying to just match up as close as we can. I'm going to double click this, and we can just hold Alt and bring that down. So we don't need to worry about this section down here going past the reference image at the moment. I'll be coming back to that, and we'll close that section off when we're creating a solid body. So moving on to the top part of this handle, again just using our manipulator tool, I can drag these faces up, just rotate them around. I can scale them down and rotate. That's the scale. And so my goal again here is to close off the top of this handle by bridging between our original face here and the top of our handle. So again, I'm just going to be using this manipulator tool to scale and rotate these edges. I usually like to just set that to 0, and then we can get a nice straight edge to match to. So again, just drag these out, move them down, and I'm ready to bridge again. And click OK. And we've created a nice section of our reciprocating saw body. So now, just to close off this section, I'm just going to drag these out, set this to 0 so I can get a nice straight edge for continuity between the surfaces. So again, I'm going to be matching up to the number of faces that I have down here. So you can see I've created 1, 2, 3, 4. Okay, we can pull these back slightly. Just so we're not interfering with our other body that I created before this demonstration. So now I'm going to use a tool called the Weld Vertices tool. So I can simply box select, and it'll weld those 2 points together, and likewise I can just click the 2 points that I'd like to weld together, and that body is now welded together. Okay. I'll turn off my canvas for now, and I'm just going to turn on our internal components, and I can hit V, and that will bring them back up. So you can see we've just got one of our components is just poking through our body at the moment, so I can just use the edit form tool. I can drag out. I don't have to worry about going in, changing sketches. I'm worrying that if the sketch will break the feature if I change it, like in other CAD packages. So I can just click OK to that. So I have one half of this body done. I'm going to mirror this body across now. So first we're just going to flatten these edges. So I can just grab all these points, these points, and then select a plane that I'd like to flatten those points to. So this will give us a line of symmetry which we can mirror our body across. So I can select my body, select my plane, and we've got, that doesn't appear to be flattened correctly, so I'll just flatten that again. And sorry. Okay, sometimes you may need to just select some of the points, and I can choose to flatten that again. I'll try it. I'll actually select the plane this time. I think I selected the parallel plane. There. Okay, and so now I'll try to mirror that again. So I can mirror my body, select my plane, and I've mirrored my body across. So you can see we've got this green line running through the middle of our body. This just tells us that we've got a line of symmetry. So basically, if I select the face on this side and I use edit form and I move, the changes will propagate over to the other side of the model. So I'm just going to cancel that for now. So now I want to join my original body with the body that we've just created. So again, I'm just going to use the bridge tool. So I can select the edges that I want to weld together. 3, 4. Got 1, 2, 3, 4. And then on this side we've got 1, 2, 3, 4. And on this side we've got 1, 2, 3, 4. And I can click OK, and we've welded those two sections together. So now I just want to close off the front of our saw. Using the edit form tool, I can just drag these edges in and hold down the Alt key, and that'll create a new set of faces. And may have a little bit of overlap here, so I'm just going to undo that, and we can drag these back. Just again using the manipulator tool. It's a very handy tool to use. So I can select these edges again and hold down the Alt key and drag them in. And then we'll bridge this section together. 3, 2, 3. I'm going to create two faces in here. And now we can weld these vertices to cover up that last bit of the body. So you can see in a matter of around 20 minutes I've already created this reciprocating saw body. In typical CAD packages, to accomplish this, you'd have to use a number of different features. You'd be constantly worrying about sketches, 3D sketches, planes, and then backlining to see if the features would actually propagate through. So you can see now I've got my body. I'm just going to show you a feature that's unique to Fusion. So if I select my body and I go move copy, I can create a copy of this body and move it up. And now I'm still on my freeform workspace, so I can grab these, use my edit form tool, can move these out, change them, change the angle of it, all within the same design, but it's not propagating back to my first design. So this is great for iterative design in the early stages where you just need to knock out as many concepts as you possibly can. So I'm just going to delete that, and we'll continue on by creating or converting this into a solid body. So to do so, I'm going to just click my finish form, and I'm going to move into the patch workspace. So I will turn back on my canvas very quickly, and I'm going to create a construction plane for the front of our saw. I turn on my origin, grab my plane, and just drag it out. So, and we click OK. And then we're going to create a sketch at the bottom. I'm just going to create a line, and drag this out. Okay, and I'm just going to use a spline. And okay, I'm just going to create a tangent constraint between the line and this spline. And now I can just use the extrude tool. Make sure my sketches are turned on. And we can drag this out. Use the symmetric option, which will go in both directions. And hit OK. And we're now just going to use a boundary fill. So this will create our solid body. So if I turn on my construction here and select the plane that I created, my body, and my patch extrude, we've got our new body here. I can click OK. So we've got a solid body now. So if I go into my bodies and I can turn these off, we've got this solid body. I'll turn off my canvas now. We don't need it for the moment, and I can turn off my construction planes. So the goal from here is to move into the model workspace and show you some 3D parametric tooling capabilities. So first off, I'm going to shell this. So I'm going to select my body. I'm going to shell this for an inside thickness of 1.5 millimeters. Click OK. And then I will split this body. And I'll use the XY plane. You can just select from your browser. And you can see now we've got two bodies here. I can just turn one off, and we've got our shelled bodies. So you can see at the front of the saw here, we need to create a cutout so our saw can actually move back and forth. So you can just select that face, create a sketch, and then a nice feature I like to use is just the slice tool. So this just gives me an idea of where I need to cut out. So I'm just going to create a rectangle very quickly and make that symmetric about the center of our saw. Drag this out a little bit, and then we can just use the press pull command. So the press pull command is unique to Fusion. So I can select these two faces and I can just drag in. So Fusion knows that I'm dragging in towards the saw that I want to cut away that material. So I'm just going to cut. I can leave it as B, and we've got the cutout for the front of our saw to move back and forth. I can turn off one of these bodies, and the next section I would like to do is create a few ribs or web to hold these internal components. I'm just going to do a few quick webs. So I've created a plane, so I can create a sketch on this plane. If I can snap that plane now. So if I just create a number of lines, I'll create one here. Tick. And okay, so now I can use the web tool. So if I go into my create tab, click web, click my three lines, and go 1.5 mil, and hit OK. The Fusion automatically knows that I want to create this web up to the body of the reciprocating saw that we created. So it's a very handy feature. But as you can see, the web is cutting into our internal components, so I'm just going to create a sketch on this face here. Create sketch, and again using the slice tool, this basically just gives me a section view of our reciprocating saw, so I can see where I need to just place this rectangle. I'm just going to do it by eye, and we can use the press pull again, select our box, drag through, cuts through the material, and I can just select the extent of where I'd like to finish. And so if I ever did choose to move that final rib here, I can just move that. The extrude will always follow through to that stage. So I'm going to apply a ruled fillet to this web. So I can select my web down here in my timeline, and I can apply a 0.5mm radius to this and click OK. So very quickly I've just managed to apply fillets to that feature. So you can see from our canvas that we've got a number of vents here. So those are used to dissipate the heat from the motor. So what I'm going to do is I'm going to turn off our internal components, just hit V, and I'll create a sketch, use my line tool, and create the first cutout for our vents. So if I hit X on my keyboard, that'll allow me to create a construction line, and click OK. Then just simply hitting D, I can add dimensions to this. Using D again, drag this down, 4, happy with that. And now I can use the rectangular pattern tool. I can box select this, and I can select my directions. So we've got one direction going this way, and the other. Sorry. So just repeat that. So I can drag this out. You can see we've got 3 instances in this case. I'd only like 2. So I can just go 2 on my keyboard and got. Just undo that for a sec and just repeat the command. Drag it out, and I can just simply turn off this one if I'd like by just hitting the tick. Oh my god. Or if I can just go 2 and drag that back in. And I can repeat this again by selecting these, get my direction, use my construction line as a direction, drag this down, change the instances to 10 in this case, and then I can just turn off these instances that I don't want, and I can just click OK. So I've quickly created a sketch for our vents. Again, I'm going to use the press pull command and select the geometry that I'd like, and I will turn back on my the other side of my body, turn off my canvas, then I can drag this out, and as soon as I come in contact with the body, Fusion knows that I'm going to cut through it. So I can go symmetric, and that will cut through on both sides, and I can click OK. So we've created vents to dissipate the heat from the motor for our reciprocating saw. So now you can see on our canvas that we've brought in, we've got this rubber overmold on our reciprocating saw. So to replicate this, I've created a sketch which we can use to split the faces of this saw. First, I'm just going to simply apply material to our bodies. I'm just going to turn off one and we'll just work with one side here. So now I'll go into my modify and I can split the face. So I just simply need to select the faces that I'd like to split. Yep. And select my sketch, and I've split the faces. So from here I can use my press pull again, select my faces, just type in 1.5 on my keyboard, and it extrude those faces out. So our nice rubber over mold here. So I can repeat this again for the back, for the handle of the saw. I can turn on my sketch again, select my faces. Oh, sorry, offset. So I can go split face, select my sketch, go through and select OK. Turn off this sketch again.
Oh, don't. Yeah, that's don't. I'll grab that.
And we can apply appearances now to these sections that we've split. So I'm just going to click on my faces, select the faces that I'd like to apply appearance to. And I'm going to apply a soft rubber appearance to these faces. And at the back, just repeating that. Just apply a plastic textured finish. And we've applied nice appearances to our reciprocating saw. Okay, so I can turn back on my internal components again. And so from here, you can see that we have these internal components, but they're not actually constrained. So there's no mates or constraints as they've been known in other CAD packages like SolidWorks. So in Fusion, they use a different type of constraints. So we use joints. So instead of locking down the positions of components, we're actually given degrees of freedom to these components. So if you see, so if I select this big spur gear and this point here, and I can change the type of motion that I would like for this big spur gear. So you can see now it rotates around that axis. So again, if I apply the same principle to this connecting rod and this pin, select my point, again repeating that for this command here, and this, and finally we're going to use a slider joint to replicate this connecting rod here. So I can just select the position that I'd like for it to revolve or to slide along. And I've created a number of joints. So if I go into my joints folder in the browser, select my first joint, right click, and then I can animate the model. And you can see this will show basically how your model works. Very impressive when you're showing to customers or trying to get across how a concept works. So I just create that rigid group and I'll show you that again. So yeah, so within 4 joints I'm able to show the motion of this reciprocating saw. So if I just hit escape there, I'll move into the simulation workspace. So for the benefit of this demonstration, I've just already completed this simulation. So I applied a 333 Newton load to the underside of our blade guard here. So you should be able to get the results. Double click results view. So you can see when that load is applied where the stresses are occurring, and you can choose which, so you can choose stress, displacement, safety factor, strain. So if I click on strain, you can see the points that are under the most strain here. So in the case of this reciprocating saw, we may need a higher degree or a higher safety factor. So what I can do is I can close this study, move back into my model workspace. I can select my gear housing. So I can just select that from my browser here. Gear housing. I can open this up. And so the interesting thing about this part is it was created in SolidWorks. So you can see we don't actually have our timeline at the bottom of the screen. So there are no features to work off here, but that doesn't matter. So if I just click on this face, go into my model workspace, use the press pull command, I can simply drag this out. I don't have to look for sketches or features of the part. See that they're not there, so I can just click OK. Likewise for this space, I can just repeat the press pull, and I can just drag it out a small bit. So just adding this material to the front of our saw will hopefully increase our factor of safety. So there's a few other features on this gear housing that could be removed. So you can see you've got this kind of messy looking fillet around the corner here. So if I just select these faces and just hit delete on my keyboard, Fusion automatically just merges or removes that feature. Likewise with this this writing here doesn't need to be there. You can just hit delete. Wait. Okay, right. Maybe not. Again, with this face here, we can just delete key, and as long as you have the correct faces selected, Fusion will be able to repair that body and should have no problems with features or anything. So another thing I'd like to do is I'd like to remove one of these ribs here at the back. So again, I can just go in, select the faces of this feature, rotate around and hit delete, and that's removed. And now I can just select these faces, go to move copy. I can then rotate this around, select the axis I'd like to rotate it around. So I'm just going to pick this point here, and so sometimes Fusion will struggle with features like this because we've got fillets. We're trying to move fillets, which can be a bit of a hassle. So I can just remove these fillets, and we can try that again. So if I select my two faces, go to move copy, hit the rotate, select my axis, and we can move that 30 degrees, and it's centered there, and hit OK. And then you can reapply the fillets if needs be. So I can save this file and hit OK. And I can move back into my reciprocating saw. So you can see now we've got this little warning up here saying that one of our components is actually out of date. So it's referring to our gear housing. So if I click on this warning, Fusion will automatically look for the latest version of this file. Once that's loaded up, okay, you can see we've got our new gear housing. So from there you can move back into your simulation workspace. You can redo the simulation and see how these changes have either increased or decreased the factor of safety depending on what changes you've actually made. So from here I'm going to move into our CAM workspace. So if I open up the mold core for this reciprocating saw, I'll be able to show you how to create toolpaths and simulate how the mold for this reciprocating saw will be created on a CNC machine. So you can see we've got our mold core here. I've got two setups already done, but I'm just going to run through and show you how to set this up. So I can just simply select my model, choose my Z-axis as our top face here, and then pick a point in our box so we can start from, and hit OK. So we've got our setup, and just close these ones down, and then I can add a 3D adaptive clearing path. I can select my tool from my tool library. So in here you can create your own tools if needs be, or you can locate tools from libraries which will be available to you on Fusion 360. So if I click OK, and if I select my height down to the bottom here, go to selection, that'll be the bottom height. So Fusion knows that it does not need to go any further than this face. And if I click OK, so you can see we've got Fusion is just calculating the toolpaths now as we speak. So you can see these blue lines are just the path of the tool, and then the yellow lines represent where the tool lifts off and moves. So in the meantime I'm going to create another toolpath, so it's just going to be a parallel path. I can select my tool again, so I'm going to use this quarter ball nose tool, hit OK, and click on my geometry. So I want to try to get the outside of our saw, and I think if I hit OK, Fusion will start to calculate that toolpath. Okay, so you can see that that's created. So from here I can then hit the simulate key. I can add my stock, so you can just see where material will be removed from. I can just change this to tail, so I can just see where the tool will be moving from. And I can click close. I can actually make sure you click this, select the setup, go to simulate, and now from here you can see we've got options to start a simulation and skip through, and I can just start this simulation, and you can see our first tool is creating our first cut, and we can just speed this up just for the sake of demonstration. Okay, so you can see our tool, our mold being to be created. So once you're happy with this, these toolpaths, you can post the G code out to your CNC machine or vendor. So I'll close these, and I can move back into my model workspace. Go back to my reciprocating saw, and so the final section I'd like to show you is just how collaboration works within Fusion. So you can see down here at the bottom we've got these comments section. So I can just make a comment here. all good. No changes needed. And I can hit post. Then I can move up to my file. I can open the details in a web. And so I can just do this in my browser. So anybody has access to this. So I can simply create this live review where people are able to so we can open this up. Oh, okay, so sorry for this now, but I'm actually going to close this down and I can start a live review session. So this live review session will allow me to create a link which I can then send to, I can copy this link, I can move back into my browser, I can paste and go. I can just enter my name, start. So basically the idea behind this is you can send this link to anybody around the world. They can open the design in their browser. They can look around, they can pan, they can rotate, they can measure components. So you can see it all comes through into my browser. It's just loading up now. So I can just rotate, look around, change different angles. You can, and from here then you can add comments about design changes that need to be occur in the saw. So like in simulation example, adding more material down to this section here or thickening that section would increase the factor of safety. So that is the principles of Fusion 360. I hope you enjoyed this demonstration and it was beneficial to you. If you've any questions, we will happily answer the questions through email after this. So thank you. Have a nice day.